wanted to demonstrate to novices how you build a unlicensed radio station if you want to. It's not that hard, actually. You don't have to obviously build your own boards like I'm doing. I'm just doing it because it's fun for me. But if you want to build a pirate radio station, and this is for educational purposes only, you have to, obviously look up the laws in your area and make sure that it's legal to broadcast, and that the power level that you're broadcasting at is legal. But in this video, I'm just going to be educationally showing you how it is done. And what I would recommend is starting off with, if you don't know too much about electronics, but you know how to wire things up and you can solder a little bit, get a PCS electronics transmitter. It's PCSelectronics.com. Their 15-watt transmitters are really good. The integrated ones, the ones that say that they have RDS and stereo and all that on the board, don't get that one. It's not good. It uses one of those single chips that is a bad single chip. It's not like this better one that I found here. It uses a bad single chip, produces harmonics and spurious about -25. So that's not good. But their PCS Electronics 15-watt, I think it's the 7015. It's the Max Pro 7015. That's what you want to get. You get that, and it comes with a little ribbon cable thing that you attach to an LCD screen like this thing. And then, see, I just mounted this inside this case. I got this case on eBay. It's a generic 1U case, and so I just put one of these PCS 7015s. This one's not an actual 7015. This is an earlier version, but it looks very similar. So I put that inside here, and that produces 15 watts of power. It comes out this jack, this BNC cable. Then you get a Wi-Fi expert on eBay sells these very good BNC cables. They're called BNC to BNC jumper cables. You can get them in practically any length you want in the US, so you don't have to wait for shipping. They're really good for powers below 30 watts. So you hook this up to the BNC output of the exciter unit, which has to be, by the way, the bottom of this thing has a bar on it. This bar is a heat sink. This has to be touching a metal surface. It's only 15 watts though, so if it's touching just even a metal case like this, that's good enough. It doesn't need a huge heat sink like the one that I have on this thing, this amplifier. So that's how you make the exciter. Then if you want to amplify it, I would recommend going to broadcastconcepts.com or Dutch RF Shop. They're the two best ones that I've found. They're very reliable and the guys are nice. So it's DutchRFShop.nl or PCS Electronics and BroadcastConcepts.com. So the PCS Electronics, they're the ones that sell the exciter boards, the thing that actually generates the signal. They also sell amplifiers, but they're overpriced, so I would not get their amplifiers. Just get the exciter board, the 7015 from them. Then go to Broadcast Concepts or go to Dutch RF, and they have boards similar to this device. I have a kilowatt right here. This is a Broadcast Concepts kilowatt. It's very efficient. It has thermal protection, so it never overheats or anything. They also sell low-pass filters, which are essential. You have a long cable that connects between the low-pass filter and the kilowatt. If you're using a lower power design, 300 watts or less, you can just connect the cable right here directly to the filter if you want. But if you have really high power, it's necessary to have a long loop, because apparently it causes a reaction with the filter. So that is, that's basically it. The power supplies that I recommend are Meanwell's This is an RSP 1500, 48 volts. Almost all of these amplifiers require 48 volts. If they're above about 30 watts, they all require that. This cable is also from Wi-Fi Expert. It's pretty thin, and it's really nice because it has no jacket and you can just solder right onto it. So, and it's called, I think it's called RG402. I'll post that somewhere, so it's, because this is hard to find, and it's really nice to have this, because you don't have to strip it, and it's also, even though it's very thin, it can handle a ton of power too. So I like that cable a lot. I have another unit over here that I can demonstrate, or I can just show you what's in it. There's the PCS unit right there. There's the stereo encoder that creates the stereo signal. You don't need that. And actually, I found if you live in a location that has a lot of buildings or mountains, you don't want to use stereo at all. It'll just make everything sound worse. If you're in a very flat location, though, using stereo will make it sound better. And that's because of multipath distortion. You can look that up. Then, so you can see what I have here. I just have the exciter from PCS going into a cable, one of those Wi-Fi Expert BNCs. Goes into here. I cut off the end and soldered it on there. And this is a 150 watt amplifier from Dutch RF Shop. Has a low pass filter with it. Have it on a heatsink with two small but pretty powerful fans. They're Chinese. They actually came out of a projector, but you can use whatever you want. There's the screen. The case is another generic 1U case that you can get on eBay. They're designed for, I think, audio people that are designing their own audio amplifiers. So you can get that, and then you just put all the stuff in there, and it saves a lot of money when you put the stuff together yourself rather than buying this whole thing as a unit. And it looks pretty pro. Like, this looks, you can put it in a rack like at a real radio station, and people would think this is a real transmitter, but it's actually been put together from parts, and you don't really have to have that much knowledge. So yeah, that's the power supply for the exciter right there. This is the power supply for the amplifier. The reason why it's kind of weird looking and there's no cover is because it's a special short 1U version of the Meanwell power supply, so that I could fit it in that case. Get one of these current shunts so that you can measure how much power it's using, so you know the efficiency, because you want to make sure it's not very inefficient, because there could be a mismatch or something wrong with it. So you put one of these on it, and then you get on eBay from China a device, one of these meters. I have one here. This is a voltage one, but they have ones for amps as well. So you put that on there, and don't get a digital one. It won't work. I tried a digital, and well, I tried only one, and I think it's because it's low grade, but I think some of the RF gets into the lines and the digital thing does not work. So you have to use one of these old-fashioned analog things, and then you just wire this onto this thing, and then it tells you how much current it's drawing, so make sure that it's working at the required efficiency and not producing too much heat. Then another thing that is really good to have, but this is more expensive. This is getting towards the more expensive end of things. But if you're really into it, I would get one of these bird meters. They're super accurate. They're military grade. They come with these plug-in elements that each have a different power level, and they tell you exactly how much power it's putting out. It works much better than something such as one of these ham radios. These ham radio power SWR analyzers. These things work okay, but they're not very accurate, and they tend to break pretty easily. They're low grade. They're consumer grade stuff. So you probably don't want to use that for like a real radio station. You would want to use a bird meter. And you want to also, you can check the SWR, even though this, like a normal SWR meter like the one I just showed you, has two needles. One is forward power and the other is reflected power. So you have to make sure that the antenna is tuned to the proper frequency. So you want to make sure that the reflected power is not too high, because that means the power is coming back in and going back into the amplifier and causing it to heat up even more. You want as much of the power as possible to be going outward. So in order to check that on a bird, you reverse this, and I actually didn't even know this for a very long time. This element, you can turn it around like this, and when you turn it around, this meter then becomes the reflected power. So you have it forward and it shows you how much power is going out, and if you rotate this element backwards, it shows you the reflected power. So what I usually do is I put a high power element in here, like whatever I'm using. Like if this is 300 watts, I have a 500, so I put a 500 in there, and then if I want to measure the reflected, I take the 500 out, I put a lower power one in there, maybe like a 10 watt, and then reverse it, and then it'll show me the 10 watts, the lower amount that's reflected. Because if you use the 500 and you just turn it around, you probably won't see much of anything if your antenna is working well. If it's not, you're going to see a lot, but you want to like have more sensitivity, so you put a lower one in there. You can get a spectrum analyzer. These are very expensive though. They're not really necessary. What I think is necessary though is this device. It's a Pura CZ. If you don't have a spectrum analyzer, this will tell you pretty much all the required information. And it's pretty expensive, but it's not like $1,000 like that. It's like $300. And it's Pura.cz. It's their FM broadcast analyzer. You put an antenna on this thing, and or you can plug the thing directly in, but you don't want to blow it out. So I put just an antenna on here, and then it shows you the frequency, the deviation. It logs like information regarding like deviation and stuff, so that you can like look at it over a long period of time. It has a USB serial there, and it has a USB there. You can plug it into the computer, and it'll give you a graph showing like how much you're modulating, because you want to be sure that you're modulating 75 kilohertz. You want it to say 75. If it's less than that or more than that, the signal is either going to be too quiet, or it's going to be over modulating and it'll get distorted and it won't sound right. So if you're just, you can get away without using one of these if you just put together one of those PCSs along with a Broadcast Concepts amplifier. It's probably okay. But if you're not sure how loud to set the volume level on your device, like whether it's a computer or a mixer board, you need one of these to tell you how much you're modulating the signal. So it's Pura.cz. It's P275 FM analyzer. It's new. They just came out with it. So this is another good thing to have. In terms of cabling, if you're using more than 100 watts, you want to use LMR 400 cable. That's what this is. And it's Times Microwave is the company that you want to use. Do not use fake LMR 400 from China. If you go on eBay, you'll find stuff that says LMR equivalent. Don't get that. It's Chinese and it's not going to work as well. This is Times Microwave LMR 400 cable. It can handle up to 1 kilowatt. And probably even a little more than that. It's just the connector that prevents it from handling a little bit more, because the connector gets a little warm. The connectors that are used, that's another thing, the connectors that are used generally for radio broadcasting, if it's below 1 kilowatt, are either the PL259 or the N connector. This is an adapter actually right here, but N connectors are the most common. They're the best. Those are the ones I would use generally. So if you want to get an amplifier and you want to put it in a case, or you want to connect it up to something, you want to get this kind of cable, which I think is RG402, but I'll look that up just to be sure, because this stuff is really good. You get this kind of cable with a bulkhead of an N connector. See, it has a mounting bracket here. So you put this on the back, like you build a metal case, and then you put this on the back of the case, and then this connects to an N connector, and then that then goes into the LMR 400 cable, because this cable is good for long runs and stuff, and it's not too stiff. It's pretty stiff, but this stuff is only good to be used inside of the amplifier for very short runs. You wouldn't use this as an external cable. It's just to connect from the inside of the case. Like if this were theoretically in a case, you would connect from this to the back of the case, and then this to the LMR. This device here, you don't need this. This is just a RF sampling device. So it samples a little portion of the signal that's going through here and puts it into this cable that I then have plugged into the spectrum analyzer to make sure that it's a clean signal. But that's not really necessary for a simple setup. It's only if you want to make sure that everything's super great, and it's also pretty expensive to get the spectrum analyzer. So I wouldn't do that. So I would just get LMR 400 cable, not the Chinese stuff, N connectors, some of these BNCs from Wi-Fi Expert. This Pure CZ thing is good. Yeah, I think that pretty much summarizes all you have to do. It's not that complicated, but the problem is there's not enough educational information on this subject, and that's why I'm making this video, because for people that, you know, they just go online and they find an FM amplifier and they try to hook it up, generally it's not going to just work. These things are not built very well. Like, a lot of times you have to tweak stuff, like add a little extra length or something, and so if you end up going on eBay and trying to purchase FM amplifiers or FM exciters, they're Chinese, and so it's going to end up making you frustrated because stuff is not going to be working right, and it's not going to be your fault. It's going to be because it's some Chinese crap. So if you go with the ones that I finally found over like a few years of experimentation, the PCS Electronics, the Broadcast Concepts, the Dutch RF Shop, the LMR 400 cables, if you go with all those things, it's almost guaranteed to work perfectly and you're not going to have problems. But if you go on eBay and you get cheap Chinese FM transmitter, it's not going to work. And so it gets kind of frustrating because you think that, like, oh, it's too complicated to, you know, like I must not be doing something right, I'm not knowledgeable enough. But usually that's not the case. Usually their devices are defective. So, yeah. And just another thing to keep in mind is that this might be obvious. I don't know how much detail to go into. But whenever you connect a device for a VHF signal, you always have to use coax. You can't use wires. There's one exception right here where I created an inductor here because it needed it. But always, if the thing is designed properly, you always use coax connectors. Never use two wires to connect. If it's a signal that's below 30 megahertz though, which is not FM radio broadcasting, but if you're doing, for example, AM radio broadcasting, you just take the two wires coming out like you would normally wire up like the power. See, this is the power going in, the actual like voltage going in, and then this is the radio output, and this is the radio input to the amplifier. So for the power, you just use normal wires, but when you connect the RF, the radio portion, you always have to use coax of some kind. You can't get away with wires like you can below 30 megahertz. So that's another thing to keep in mind, so you can't just use wires. Another addition, if you are going to be using and testing a lot of amplifiers and exciters for FM broadcasting, and you're not sure if they're going to work, and you want to be able to use this device to analyze it for a while before actually going on air, you're going to need a dummy load. And that's something that I haven't mentioned yet. So a dummy load is an antenna. This is a dummy load underneath this fan. It's basically an antenna that just absorbs all the signal. So you hook up the coax cable to this, and it absorbs all of the signal. So if you don't want to actually broadcast on the air yet because you're not sure everything's working, you want to analyze the signal first to make sure you're not putting anything weird out there that you shouldn't be. You use a dummy load like this. This one can handle up to 100 watts, but one that I found that is much superior and cheaper, a paint can. So it's a paint can with a cable connector on the top of it, and you actually fill the thing up with oil. You get this oil stuff. It's transformer oil. You get this, and you fill the can up, and then basically all the RF, the radio energy, heats this can up. So that's why I have that fan there. And it can handle like a kilowatt for about 10 minutes. So it's really good. It lasts a long time. It has a low SWR, and it's very cheap. So it's called it's from MFJ, and it's a cantenna. It's a dummy load cantenna. So that's from a ham radio site, but it works really well for FM broadcasting as well. So that's just something else I was going to add to the video. So yeah, I think that's it. So I wanted to add a little additional information here. I have these other filters here. This one you get on eBay. It's called a 1 kilowatt low pass filter. Definitely don't use this one. It only produces 200 watts with this one, and it gets extremely hot. So don't use this filter. This filter can probably only handle about 100 watts based on the size of these coils I was looking at. It's really never going to handle a kilowatt, so they're just completely lying on this. This, however, is a really great low-pass filter. So this filter is called, it's from Dutch RF Shop. It's dutchrfshop.nl. It's their 1 kilowatt low-pass filter. You might be able to use I think they have a lower power one as well. You might be able to use that, but I haven't tested that. I tested this on it, and it works great on all frequencies. It attenuates the harmonics like down to at least -50. So it's very good. And the spacings between these coils, it doesn't get too hot either. So yeah, I just wanted to add on to the video. So that's about it. Thanks for watching.